Hi friends, welcome to the first lesson in the Network Address Translation Operations and Concepts module. In this lesson we'll be discussing why does NAT exist. So here you have the internet and a bunch of hosts on the internet. One of the rules to how the internet works is that everything on the internet needs an IP address. An IP address looks like this. So if we give all these hosts IP address, they now have the ability to direct data to each other. For instance, if host A wants to speak to host D, it can send something to host D's address. Without IP addresses, this would be impossible. Moreover, since host A also has an IP address, it can provide the source IP address to host D so that host D can respond back to the original sender. That's how the devices on the internet communicate using these IP addresses. So an IP address is 32 bits. A bit is simply a digit that can be a 1 or a 0. So when we say an IP address looks like this, what it actually looks like to a computer is like this. It's actually 32 combinations of ones and zeros, which we then break up into chunks of 8, which we call an octet, and convert into decimal numbers to make it easier for us humans who don't speak binary. So every IP address is simply a unique combination of 32 ones and zeros. What this means is that there is a finite number of IP addresses in the world. Since we have 32 bits and each one of them can be a 1 or a 0, we can calculate the total combination of IP addresses that exist by taking 2 because there's only 2 possible values for each bit, and raising it to the 32nd power, 32nd because there are 32 bits in each IP address, to give us the total number of addresses in IPv4, which is 4.2 billion. Now, the original intent of the internet was that every single host was meant to have a unique IP address, which means we could have no more than 4.2 billion hosts on the internet. But we realized we were going to run out of IP address. A simple example of that is, if you think about it, right now the world has about 7 billion to 8 billion people on the planet, which means if we wanted the entire world to be able to communicate on the internet, which is a desirable goal, we definitely don't have enough IP addresses to account for all of them. Moreover, a lot of people have multiple devices that are speaking on the internet. For instance, how many of you have a mobile phone that connects to the internet, or a laptop that connects to the internet, or a tablet that connects to the internet? All these devices that need to connect to the internet need an IP address. And so we clearly are not going to have enough with 4.2 billion. The long-term solution was to recreate an IP addressing scheme known as IPv6. An IPv6 address has 128 bits, giving us a significantly larger address space to be able to give addresses to all the types of devices we need in the world. But moving from IPv4 to IPv6 is going to be a long, drawn-out process. To give you an example of that, I'm recording this class in 2020, and IPv6 came out in 1998. And as of today, only about 20 to 25% of the world is on IPv6. So we need some sort of solution to help us stretch the IPv4 address space to accommodate all the devices in the world. The predominant solution for that is NAT. NAT provides us a way to extend the IPv4 address space so that we can accommodate all the devices that are currently on the internet today. How does NAT do that? That's a great question. What NAT does is it creates a set of IP addresses that are reusable. Specifically, these addresses. So you have the 10.0.0/8 space, the 172.16.0.0/12 space, and the 192.168.0.0/16 space. These addresses are referred to as private IPv4 addresses. They're also sometimes referred to as RFC 1918 addresses, because this is the document which formalized that these are private addresses. In either case, these private addresses are reusable infinitely anywhere in the world. So that problem of running out of IPv4 addresses goes away, since we can simply reuse these as necessary. All remaining addresses, for the most part, are then known as public addresses, and what then translates between these private addresses and the remaining public addresses is NAT. So let me show you how that actually conserves IP address space. So here we have a typical home Wi-Fi network. This particular Wi-Fi network is using the internal address space of 192.168.1.0/24. Each device on this network has its own IP address in that network. So this mobile phone has the IP address 1.11. This desktop PC has 1.22. This tablet has .33, and so on. Since these devices are connected to the internet, they must have an IP address, and they each have an IP address in this private address space. But when they are speaking to the internet, the router over here is translating their addresses to this public IP address, 210.26.98. This allows all 5 of these devices, or however many devices would exist in this particular home Wi-Fi network, to all use one IP address externally. Notice we have 5 devices over here, all sharing one IP address. This gives us a 5-to-1 ratio of conserved IP address space. That's the goal of NAT. That's how NAT actually conserves and helps us extend the life of the IPv4 address space. But it actually goes a step further. This house likely exists in some neighborhood, and it's very likely that all the houses in this neighborhood use the same private IP address space for their internal Wi-Fi network. And as long as each of these routers are translating those private addresses into unique public addresses, we will have no problem communicating with other devices on the internet. One of the rules with the internet after NAT is that any communication on the internet must be from public addresses to public addresses. Any traffic that includes a private IP address will be dropped. So this host with a private address, when it's communicating with C, after passing the router translates it to a public address. And as far as the internet is concerned, it's a public address speaking to a public address. When the traffic comes back to the router will then untranslate that packet to pass it back to the private host. Therefore, we maintain the rule that on the internet, only public addresses can speak to each other, but on the private side, you can reuse this address space infinitely so that we can extend the life of IPv4. So that's the purpose of NAT. It's to extend the life of IPv4 addresses. I hope you enjoyed this video, and I want to thank you for watching. Hey YouTube, want to learn more? Check out the rest of the free network address translation videos. Then, when you're ready to take it a step further, check out these courses which teach you how to configure, verify, and troubleshoot NAT on Cisco routers and firewalls. As always, if you enjoyed this video, don't forget to like and subscribe. Thank you, and have a wonderful day.